Hello and welcome to our presentation. Today we're going to talk a bit about how to evolve user interfaces through composition and hypermedia. First a bit about ourselves. My name is Asbjørn Ulsberg. I'm a developer experience janitor and all-round developer and architect at PX.
And my name is Thomas Presthus. I'm a consultant. I work mainly with software architecture and domain-driven design at clients. And if you have any questions or comments, please bombard us on Twitter. Tell us we're right, tell us we're wrong. Make questions. We're all up on the screen. So I guess we'll just start. So we're going to look at some problems. Now, as developers, we think that APIs are great. We tend to focus on them. When we consume other services, this is where we start. When we look at other people's documentation, this is where we start. But there's a problem because most users don't use APIs, or at least the companies that I work with create systems that have actual user interfaces and actual users who expect to be able to interact with the system through user interfaces. And back in the days, this was pretty easy because we had our monolithic services that looked perhaps like this or more with vertical slices, but everything was still contained within one boundary. And when we were developing a new feature, it was pretty natural for us to develop the user interface at the same time as we would develop the data layer and domain models and application interfaces. But fast forward to 2019 or some years ago, and now our system looks more like this. It's a plethora of small services or big services. Doesn't really matter if it's microservices or SOA services. But our system is distributed. And we have to really rethink how we build them, because where is my front end? And after we did this, maybe someone would recognize this kind of sentiment. Product comes along and says, oh, you've spent a year tearing our system apart into Microsofts or microservices or something we don't know, but we need to deliver some value now. And to product services or not services and APIs aren't necessarily value. They value the interactions that users are able to make with our system. And so before we delve into composition, we have to make some considerations. Like, how does our organization look? How many developers are in our organization or in our team? If it's a small team, maybe we'll be able to make more monolithic systems. Maybe if it's many developers, we need to think, how are we going to not make bottlenecks? How can we streamline our development? How many teams are there? How does our organization look? How will that impact our approach? Do we have one system? Do we have many systems? Is it one application, one product, or is it many? And there's also some needs and requirements and expectations that we need to preserve. Do you want to have a uniform look and feel? Because that's what most people expect when we start using an application. Is this an internal application where we can take shortcuts because we're able to ramp up and train the people or the staffers who are using the application? Or is it a public project that your grandma will be able to use? So who are your users? And also there's pace and speed. How fast do you want to deliver? What does product expect? What's our time to market? Can we wait a year? Or do we have to go into production tomorrow? And that will impact how we organize and how we develop our frontends. And of course, there's the skills and existing architecture in the organization. Do you need training for developers and architects? What kind of architectural alignment do you have? Is your application ready to embrace composition or not? What's your technology stack? Some technologies may be better suited for composition straight off the box than others. And there's, of course, the operational perspective. Do we as developers push it into production? Do we have the ops team? Do we have something in between? That will impact how we package things. So what is it actually that we want to compose into interfaces? what you want to achieve? Well, of course, there's the development scaling, and that can be organizational or from a product perspective. The pace and the time to market. We want to work effectively, not kick each other's legs as we commit code and deploy things. We probably want to maintain distribution and cohesion between a system, both of the processing, but also of the responsibilities of the services that we create. And of course, we want to provide composition of the user interfaces. So there are two distinct aspects to consider here. First, there are the technical patterns. How can we actually solve composition in a very technical way? These are patterns and solutions that are mostly cookie cutter or recipes and approaches. And then there's the deeper understanding with how can we dive into modeling the interactions that our user is going to take and maybe look at it from more domain-driven perspective. In this talk, we're going to focus mostly on the technical patterns, but we've thrown in some modeling pieces as well that I think maybe you will appreciate. So where do we start? There are some pitfalls to this, and there are a lot of talks already out there that discuss composition of user interfaces, but most of them kind of tend to use hello world examples, and it makes everything look really easy. Because the scenarios are simple, but the real world, everything is more complex, as we as developers know. So if you remember this slide, all our services, but where is my front end? We can start looking at the first pattern, which is probably an anti-pattern, but the one you'll see most commonly, both in talks and also in the real world, and that is the monolithic front end. So with the monolithic front end, we embrace composition in a separate front-end application. We create a separate repository where we version our front-end. This is an application that has its own life cycle and doesn't affect the other services. It's usually a data-based composition, which means that our application invokes APIs from other services that it depends on and composes this together with its own look and feel. But this also requires our front application to have intimate and intrinsic knowledge of how the inner workings of the other services that it depends on. And this application has the sole responsibility for look and feel and for a placement and layout of elements and how you will engage with the application. Now, making monolithic frontends takes extra effort to handle failures because as developers, we tend to abstract away network calls and service calls. So when you work in the front-end application, you'll probably not be aware that you're calling other services. You'll hide it behind services and view models and whatnot. So in order to handle failures or be resilient to failures, what happens when another service is down or not responding? Are you going to degrade the experience or just not work at all? But one really positive thing about monolithic frontend is that it's really, really easy to work with user experience. Because if you have separate UX people in your organization, it's way easier for them to make adjustments when they only have to think about one code base and one application that serves as your user interface. So UX people tend to really like the front-end monoliths, but that doesn't really mean it's good. So how does it look like? It's pretty easy. It's like a front-end, and it depends on many services. We've seen this before, haven't we? And what we've actually done is take this big monolith, and we've broken the backend services down to separate services, but we still have the high coupling and the low cohesion between our front end and the other services. So in practice, we've gained pretty much nothing. Throughout this talk, we're going to show you some samples, and we've created a toy application. It has an architecture like this. So there's an administration front end. There are two entity services, which we don't really like, but it's easy for the example. and there's an authorization service and a navigation service that serves cross-cutting concerns. So I think Asbjørn wants to show you this application.
Yes. Let's hope the demo gods is with us today, because the last commit was made just a few minutes ago. So let's have a look here. So this is how the structure of the application is. We have an admin project separated into authorization, customers, and navigation, and then transactions.
If you collapse the admin project, you'll see, just collapse all, I think. You'll see the other services, authorization, customers, navigation, transactions. But this structure is also mirrored inside the administration application.
And if we look into the customer view, you can see that, no, the view model, sorry. Customer view, you can see that we have a view here that both has information about the transaction and about the customer. So if we just take a peek at how that looks like. This is how the application looks like. So we're logged in as Bunchbox for SquarePants. That information comes from the authorization service. If we look at the customer list and click into a customer, here's the customer information, and here's some transactions for that customer. And everything is composed within the same view with intrinsic knowledge about the data model coming from the API. And we can see that the data is coming from the API on the customer service here. So here we can see that the customer has responded with JSON corresponding to what we see in the view here. So that's how the front end looks like.
Yeah, so as you saw, this front application knows everything about the data about depending services. So when we're doing front-end composition in a monolith, the data API is a contract. If you break it, you'll break the entire application, which means that they become bottlenecks, and you have to do lockstep deployments. If you're going to provide new data, you'll have or compose the new data, you'll have to make changes both in the front end and in the service that contains the data. If you make changes to the service that contains the data, you'll have to update the front end in order to not break your user interface. So this creates lockstep deployments in the fact that if you're not careful about how you version your APIs, you'll have to deploy both the front end and the other services at the same time, which scales really bad if you have several teams working on them. And it also loses autonomy because it becomes more tightly coupled. And, well, you get all the pain from traditional monolithic architectures and none of the gains. But it can be really quick and easy to get up and running. And if you're just starting out in a distributed system, it might be a conceivable way to start out. And there's also the advantage of you can implement it on both the server and the client side. So if you're doing server side, like we're doing here, you're composing with Razor views and MVC or something. But you can also do this with a single page application using Angular or React or wherever fits their needs. So those are problems. Now we want to look into composition, and we found this dictionary quote. Composition, it's a noun, it's a mixture of things that are combined to form something new, from the Cambridge Academic Content Dictionary. And that's what we want to do, because if you remember this slide, we have our services and no front end. What we actually want to do is we want to create a bit of user interface inside each service, because we want to assign responsibility of individual services and features and domain to different teams. So team A might be working on these two services, team B on this one. We have one team that are responsible for 3 different services and 3 different domains. We have another one for these two, and there's a team that takes care of this. Now, when we place a bit of user interface inside each service, those teams are responsible for maintaining those user interfaces because they know how their service works. They are the experts on their domain, and they can make the best choices and present the user interface in the best possible way. So we actually end up with the user interface being some conceptual, logical thing instead of a big block. So the user interface becomes a shell that composes different aspects or different interfaces from its other services. That's composition, so I think we're done. Or nah, just kidding. So there are some existing technologies that we can use. There's ESI and SSI, or edge side includes and server side includes. These are really old technologies. They've been around for perhaps almost as long as the World Wide Web. When we use edge side or server side includes, we establish some middleware component that is responsible for merging content at the edge or before our responses reach the user. So this can be part of the application layer with SSI, or it can be an independent component that I accomplish with edge side includes. So we would route our requests, HTTP requests, to a primary service that is responsible for handling that request. And the primary service will then prepare a temporary response that contains some placeholders with instructions of what kind of content do we want to be included here. And then this middleware will fetch resources for those inclusion parts and embed them into the body of a response before it's returned to the requesting client. So with edge side includes, we compose on the edge of our application. It's not part of the application layer itself, so it's out of bound of our application. We usually do this with reverse proxies or caches or load balancers. Varnish can do it, Nginx or Apache are all able to do this. And we mostly use it for static content, like maybe a banner or top header or a sidebar, things that doesn't change too much. And when we do this, we have to be really careful. I don't know, how many of you are Norwegian in the room? Yeah, so we've all used Altinn, right? The Norwegian government portal where we send out tax reports. I think it's close to 10 years ago. They had a cache misconfiguration in their big IP load balancer. So when people started logging in, they wouldn't see their own name, but someone else's name, because they were cached. And that can happen if we're not careful about how we model our content and resources. So usually we care. Now with service that includes, we compose at the application level or in the web server that serves our application instead. So Apache can do this, or IIS can do it, but we can also do it directly in the pipeline of our service applications. So if you're using MVC, it can be a middleware component, or you can do it with Node or pretty much wherever. It's pretty easy to just fetch other resources over HTTP and return it. And with service that includes, you have the same problems as with ESI, with dynamic or personal content. Be careful. So just a quick example of how an edge that include can look. Say we have a request to the front page. It's with HTTP GET. It reaches Varnish, which is our middleware. Varnish handles the primary request done in a service that returns a body that looks like this. We see that we have two ESI tags here that includes our navigation service and some related content. Now what happens is that Varnish will actually go out and fetch those resources. So our primary request handler doesn't know what content will be in this. It only knows that some resource exists with this relation. So Varnish will fetch those resources from separate places, and the responses looks like this. And then it will embed or merge it into a new response. So we went from this preliminary response into a composed one that contains all our static content. And this response is then, of course, returned to our client. So the positive effects of ESI SSI is that it scales really, really well with static resources because you can leverage caching. and open source components are readily available because this is a standard language specification that you can use. Some of the downsides are that your primary handler has to know about which resources are to be included. So even though it doesn't know about the content of the resources, it has to know about the resources. And it's mostly suited to embedding static bits and not content that would change per request or per user. Now, server-side composition can be more interesting because, well, if you're not doing completely static pages, you will probably want to have some dynamic content. So this is what we see in most talks that concerns user interfaces and composition in service-based architectures. They keep their services and frontends in one big solution, and they show how simple it is to consume APIs from underlying services and combining them all into a frontend. This is also what happens in the toy application that Asbjørn just showed you. So when we do this, we build applications that compose and render pages on the server. We can make full pages with layouts, or we can use partials and combine them together. So we can actually link several applications and make layers of composition through chains of responsibilities. It looks pretty much like the Backend-For-Frontend pattern, but it's without the backend part, so we have more like a frontend for the frontend, actually. And it's technology agnostic. You can do this with any tool stack, with any stack or tools you use. And you can also use it, or it's also used in isomorphic applications, where maybe you want to prepare layout and immediate page compositions for SEO or search engine optimization concerns, or because of loading times and for caching and responsiveness. And you can share the same code on both the server side and the client side if you're using Node.js on the backend and some kind of JavaScript SPA in the front end. And we're going to go pretty quickly to client-side composition. Yeah. So this is what we want to demonstrate today. Usually you accomplish client-side composition within a single-page application framework with JavaScript or TypeScript or whatever that allow us to piece together blocks in real time as they happen in the browser. So you don't have to know about anything on the server side, but the client application has to know about the composition. But when we do it, we often tend to end up with a monolithic single-page application instead. So we're back to monolithic frontend, just placed in the browser instead of on our server. So we need to rethink how we architect them. We can do techniques like communicating between the blocks through the DOM with events. We can use iframes and pulse messages between them. And we end up with a shell application that only dictates layout and look and feel instead of knowing how our services are going to be presented. So it's really important to not create just another monolith. We are used to developing single-page applications in a monolithic fashion. We are used to creating one big single-page application, and it knows about everything below, and it does HTTP calls and composes right in your browser. But please resist the urge and try to break those established patterns and push for some change. You try to use web components instead. Web components is an HTML5 standard, and when we use it, we want every service or the team that built the service to build their own components in technology stack that they choose and wrap it in custom elements. So it will look like this in the browser. This is the catalog related from the ESI example. And we treat these components as an open host service with a published API. This means that the name of your component and any attributes or events that it consumes or produces are part of your contract. So the front-end applications that compose them only has to know about those contracts. And you have to version that contract, of course, and you have to treat it as an API. So we're going to do some more demoing. We're going to look into the admin frontend and now the authorization servers, how we can leverage custom elements. So we will show it soon. First, we're going to use some polyfills because old browsers doesn't support custom elements, so we'll have to register them. And on our admin frontend application, we're going to include some JavaScript from our other services. And then we're going to look at the authorization service. Now we're going to create a new element which looks like this. It's just some lines of code with JavaScript. We call it the authorization user profile. And we have a means of rendering that content. So here we're going to make a div that contains the logged in user's name. Pretty simple. And we're going to register this element using window custom elements define, as you can see on the slides. And we're going to register it as the authorization user profile element. Looks like this in total. Now in our layout in the admin frontend, it used to look like this. We have a header with the navigation and a view model that contains the logged in user's name, which is fetched by an HTTP call down to another service. Instead of that, we're now going to do this. So in our front end, we have the authorization user profile, and that's it. We don't have to care about view models. We don't have to care about the data. This will just happen magically. I like magic. So let's have a look at that.
Yep. Let's check that branch out or tag.
If you look awkward, it's because we can only see your screen on that monitor. So we'll, yeah.
Now we have to wait for a recompile. Wow.
Oh.
Sorry about that. Yeah. It should be up. Nope.
This worked right on my computer just some minutes ago.
Yeah, I worked on this as well. This is strange. Let's try to recompile. There we go.
Recompilers works.
Yep.
Yeah. Thank you.
And I can see up in the right corner, the username there is with a red background.
Yeah, so if we open the authorization service,
The view was
fragments.js, you can.
This one. You can see here the background color is red. Now if we change it to blue, it's blue.
Display. Woo!
And this isn't strange at all. But if we look at where the data is coming from, it should look a bit different.
I think if you go back to browser, you can use it to inspect elements.
Yeah,
on
sure.
the. So we can see that it's an authorization user profile element, and there's some data inside it. And if you can tell view page source or something, and just find the authorization user profile. Now, if you look here, you can see that there's no content inside of the authorization user profile, which means that this page served from the front application actually has nothing, but still we can see the blue background changing with the name. This is because that component is served from a different service that's only included through JavaScript.
Yeah, we should have had that in the log header as well, but I don't know.
Right, that's the customers.
Okay. Yeah, well.
Yeah. Nevertheless, so inside this service that is served on a different port, different application, we can actually make changes to how we present the contents of this element. So the admin front the admin front-end application no longer has to know about users at all. It can just say, okay, I want to show the user authorization user profile, and that's it. It's up to you to present the logged-in user if there is any. We don't have to keep that state in our view model in the front application, and we don't have to do any background calls or fetches to the other service. So I think that's back to PowerPoint. Yeah, so that's for a demo sorry, of the custom elements. So the positive sides of this is that web components is a specification. It's part of HTML5, and all modern browsers support it out of the box. And there are polyfills that you can use, so you can support old browsers as well. It's technology agnostic, and this is a pretty big point because it means that every team can choose what kind of technology stack or language they want to create the custom elements in, as long as they can expose a JavaScript file. You can choose to use .NET stack or Go or Scala or Java or anything. You don't have to use the same across the different services. And this is kind of a big advantage in some organizations. And also, it creates a very clean interface with a published contract between services, and it's easy to document these interfaces because it's HTML. It's a component. It has attributes and events, and that's it. Some cons are, of course, the browser support, but we can solve this with polyfills. The bigger con is that it requires a shift of mindset. We have to rethink how we create client-side architectures, and this can be hard to introduce in existing teams if you're used to developing monolithic frontends. Now we're going to look into hybrid composition, or mixing client-side and server-side composition. And this is a really powerful technique, especially in legacy systems when you want to start introducing composition and where you don't have the advantage of starting out from scratch. So when we do this, we have to start classifying our needs. And Al Balkan has written a large white paper where it goes into demystifying and classifying and defining applications and sites by differentiating websites from web applications. So websites, those are documents. They have static content, they are content-centric. Sites are geared towards content consumption and not content creation. These are connected via links, and it's what we know as the World Wide Web, essentially. And then we have web applications. These are tools. They are more behavior-centric, and they're geared towards creating and manipulating content instead of just consuming content. And if your site is geared towards the sites, not applications, you're probably better off using server-side composition. And if you're more towards the behavior-driven and content is created via your application, you probably want to do more client-side stuff. So if you take these two extremes, at the one you have only server-side composition and integration, and the web applications that are behavior-centric, you might end up with an application that lives almost entirely in your browser. Then there's a sweet middle point in between the hybrid approach, where perhaps you want instant feedback, you want to create a progressive application, you have content for consumption as well as creation. You can just drop a note, read more of it at microfrontends.org. And we're going to demo that as well. So our architecture from before looks like this. We're going to touch into the front end and the customer service and the transaction service. So in a customer service, we're now going to create a racer view in a controller. So we have a customer profile controller. We want to return a customer through a view, so we get it from a repository. This is straightforward. Looks like this, the controller. And then we have a racer view, which is backed by the customer model. We're going to use a bootstrap card. And our model has a name and a phone and email. And this is our racer view. So in the transaction details that we saw in the previous demo, we want to actually add this card. So we've introduced another element to our contract. We have the customer ID. So this is the way that the transaction view can communicate with our customer service through a custom element. It says that I want a customer profile card for this customer. So the attribute is part of the API or a contract. And we end up with a transaction details view that looks like this. This is the front end, and I think we're going to show that as well.
Yes.
That's final transaction.
Yeah, let's just close this.
Yeah.
Transactions.
Now you can see that this transaction actually contains the customer information box with the customer Michael J. Utter as the phone and as an email. Perhaps show another transaction as well if you take the next in the list. So this is another customer. And if you look at the source code, it will just include different customer IDs.
And if we now look at the customer service, you can see that we have something as strange as HTML coming from an API. So that's kind of what's different here. It's that the API itself is serving HTML to the client, and the client is just composing it together without knowing anything about the intrinsic details of that HTML.
Can do some coding, I think, or
yeah, we can change. And we can see the profile card served by the API. We can add username.
yeah. And since we're working with Razor, we get IntelliSense. We have a view model. We don't have to both update our API and then the JavaScript service and that consumes the API. We can do everything directly inside Visual Studio Code.
Now you can see we've added the username, and it should also be in the HTML returned by the API.
Yeah. Yep.
Could we see how the web component is?
Yeah, we can come up the talk. Yeah, it's on GitHub, so you can. Yeah. We're going to talk really quickly about modeling composition as well. Now, the canonical example when talking about composition is using Amazon, because everyone knows that Amazon composes the interfaces because it's big. So there's the image service that contains the image of this book. There's perhaps a cart service that contains the add to cart button, as well as the shop mini cart. There's a pricing service that gives you a price. But when we go ahead and start breaking down this for ourselves, we're used to seeing this architecture diagram with the front end depending on services. And how can we go to what Amazon does? Well, we need to use dependency inversion. So we want to reverse those dependencies so our services knows about models in the front end, because if we're going to compose like this, we can't have the front end knowing about our services. So when we revert them, we introduce models for interaction. So we want to actually model composition through compositional models. And it can look like this. So instead of our front end having to know anything about services, the front end becomes just this logical thing or being instead of an imperative shell. And we have compositional models for different aspects of our site, and those services can fulfill those models. And we can actually model layout, we can model content, relations, interactions, navigation. We can model templating, look and feel, and forms. We can how we capture data and intent and behavior. And those are all parts of the user experience that we can actually create models of. And we're going to show you a case for this. It's search and filter. So say that we are a payment solution provider and we help merchants receive payments from their customers. To ensure high conversion rates, we provide several different methods of providing payment. We're going to use credit card and invoices and a mobile pay. And sometimes merchants receive support requests from their customers. They need to find specific payments in our administration portal. And this requires a user-friendly search and filter interface. So we went to the UX people and we went to architect and said, yeah, this is a payment search front end. We have a payment search service, and we have credit cards and invoice and mobile pay. So we went to our UX people and they said, okay, it can look like this. You want to search or filter by transaction number and date and amount, and there's a search button. All nice and well. And we created it, and then Pro said, but hey, we need to filter on payment method specific criteria. So if it's credit card, you need to sort or filter by primary account number or credit card number and expiration date and the cardholder's name. But if it's invoice, you want to search by invoice number or due date or social security number, or mobile pay, you might want to filter by phone number. So our model actually looks like this. It's credit card with its own invariants and invoice with its own invariants. And these aren't that similar anymore. So we actually end up with the payment search frontend having implicit dependencies on our services and has to know about their inner workings in order to provide a good user interface. And this can be fine if you only have 3 payment methods and they don't change. But if you have a strategy of implementing 4 new payment methods every year, it might turn into a tire fire, because you add 1, you add 2, we can manage this, but then I'm going to add 3 more. And what happens is that the payment search frontend essentially becomes a bottleneck. Everyone has to push code there, everyone has to make changes there. So if you have different teams that maintain those different services, they are all going to have to make changes in the frontend. This doesn't scale. So we've lost autonomy, and now we have essentially a distributed monolith. So what can we do to prevent this? Well, we need to invert the dependency graph. We need to use the dependency inversion principle and do some modeling. So let's start to look into how a model like that can look, shown here. Maybe we have payment methods that we know already, but then we have a model for the payment filters. And these contains attributes for methods and criteria and types and widgets that we can actually make a frontend that can react to these concepts. So a payment method will actually register its filters with the payment search service, and the payment search frontend will get all available filters from the payment search service. And we can introduce a cache so we don't hit any performance issues. And then we can actually build up a payment search frontend that only has to create dynamically a user interface for this model. So if we try to make a protocol from that previous model, it can look like this. We have a payment method credit card. It has some filters. It has an input attribute or property. We say we want this to be a text box. And then for expiration, we say, OK, we have a month-year widget, but we also have some requirements. It has to be a date, and there's a rule that it needs to be in the future. This is way of modeling invariants in our compositional models. Now, in essence, this is database composition, but all our independent payment methods, they actually conform to a model with a published language protocol. And this represents interactions that our user can actually make in the application, in the context of search and filter. So the front end is independent from and not aware of any of the underlying services. It only knows about the model, and it's driven by the defined protocol. And that's about composition now. It's your turn to talk.
Thank you. On to Hypermedia. Can I see a raise of hand how many here knows what Hypermedia is? Okay, roughly 10-20%. How many here considers themselves a web developer? Okay, roughly half. Interesting. Let's see if those numbers change during the next few slides. Before we dive into what Hypermedia is, I'll do a short history lesson. Who can guess how many years the concept of Hypermedia has existed? Yeah?
Yeah, we had hypercards back in the 80s.
80s, okay. Any higher?
Or lower.
60s? Any higher? Okay. I'm going to beat you all and say 90 years. This man, Luis Jorge Borges, an Argentinian author, wrote and thought about the concepts of hypertext already in the 30s. And he wrote a book called The Garden of Forking Paths in 1941 that has the concept of hypermedia or hypertext, where however you read the story refers to pages in another story that when you follow the story in different directions, you end up at different places. And he follow up that with the book, the Book of Sands, with more hypertext ideas. And then it went a few years, and then we're, as you mentioned, onto the 60s with Ted Nelson coining the terms hypertext and hypermedia. In the first published reference was in 1965, and in 1967 he worked with Andries van Dam to develop hypertext editing system at Brown University. And then in 1968, Douglas Engelbart created the online system and had what's called the mother of all demos. It actually had a Wikipedia page called exactly that. And it was a system with a mouse pointer, hypertext editing, word processing, email, and a windowing environment, all in 1968. Many of Engelbart's developers went on to start the Palo Alto Research Center. You may know it as Xerox PARC in 1971. And we all know what came out from there. This, for instance, HyperCard. In 1987, Bill Atkinson created HyperCard, and it was really before its years. It was sort of like Xcode before Xcode. It had a programming environment. It was AppleScript before AppleScript. It had Near English programming language. It had just-in-time compilation, so it was Java before Java. It was Interface Builder before Interface Builder, which was Visual Basic before Visual Basic. And it was Flash before Flash because it had animation. It was FileMaker before FileMaker because it had a database. It had a built-in debugger, and it had Fix and Continue before Fix and Continue existed. So it was pretty advanced. And then in 1989, Tim Berners-Lee created the World Wide Web, as we all know. And in 2000, Roy Fielding published his doctor thesis on distributed system, where he coined the term REST. But what is hypermedia exactly? In basic, it's pretty much just links and operations. So what are operations? We can look at them as affordances. Like a cup wants to be lifted and a button wants to be pushed. That's their affordances. And that's how affordances is supposed to work in hypermedia. Do people know what to do based on what they see? Is the affordances of physical objects in the real world? And if we look at affordances in the machine world, we can say that do the machines know what to do based on what they see? So I'm going to throw a few metaphors at you, and I hope some of them sticks. You can look at hypermedia as a description of what the next request is going to look like. Sort of like a recipe. Or like a map. Not a map, actually. Instead of using a map, hypermedia is using signs when you drive around in the city. And you follow traffic lights. And all of these tell you what to do at every opportunity. You interact with the real world, and it tells you what to do. It guides you, guides your direction. And by doing this at runtime, you can accommodate for when in the day or what state whatever you are interacting with is in. So it can be open or closed depending on which time of day you visit a store, for instance. This can happen in hypermedia with an API as well. We saw a raise of hands of how many new hypermedia and web developers. So let's look at how hypermedia actually looks like. This is hypermedia. How many has seen this piece of HTML or something similar before? Yeah. Over half this time. And this is also hypermedia. This is hypermedia. And this is hypermedia. So most of the people in this room know hypermedia already. But how can we transport our knowledge of HTML to the world of APIs? That's the problem, right? We have then a hypermedia-based composition, where we try to employ web semantics to drive composition. And composition mechanism is shifted from the underlying services. We model interactions as relations or hypermedia controls. It provides context. It provides a navigation handles. And we model the services as a protocol. Composition can take place both on the server and on the client side. So if we take a basic JSON response from an API like this is a customer object, and we just change the ID into a URL and add a property called operations that describes what can we do with this customer in its current state. That's the point of the operations object in there. It describes everything we need to know in order to change this or do the update action on this customer. So then the issue is, how do we translate this JSON coming from API into HTML? Well, we have everything we need inside this JSON to actually perform the action. So it's just to translate it into HTML. You put every metadata, like the HTTP method, the target we are supposed to perform the operation on, and the name of the action or the operation in hidden fields, and everything else is input fields. And this is, in my example, is not coupled to the model of the server. It's actually coupled to an intermediary model with JSON LD, and the model is provided by schema.org. So all the names you see in here are actual properties or attributes you can find on schema.org. You can just type schema.org/birthdate or /telephone, and you can read about what is a telephone number. So you get all the semantics, and you bind to schema.org's semantics and that model instead of the one provided by the server. So Hypermedia-based composition can be built on existing standards. You have HAL, collection plus JSON, Siren, JSON LD, and Hydra. You can, of course, create your own as well, but draw inspirations from existing work. The key thing here is to create a protocol. Make whatever you use to compose your interface into infrastructure. It should just be a protocol that is fed the operations from the server side, from the APIs. And the interactions should be driven from there. No business intelligence or business logic should exist in the front end. So let's have a look at how hypermedia-based composition can look like. Oops. This is hard. There we go. Now we just need a restart. And we can just have a quick peek at how the edit view of the customer looks like before we introduced any hypermedia. We have a lot of hard-coded stuff inside a form. And it looks like this, and if we edit, and yeah, let's give him a new name. We should see the JSON for the request and response right here. So here we see the put request coming as hard-coded from the client. And now if we check out this branch and just wait for a little recompile. This should still hopefully work. Now we have had a restart, so the name is reset. Don't mind that. But if we now go into here, we can see that our response has changed quite a bit. We now have a context that is JSON LD for just describing what am I looking at, what kind of object is this. But the important part is the operations here. Here you can see the required. These are the required fields that we need when we are performing this action. And if we now take a look at the edit view, it's much simpler. We have a list just going through what operations we have, and then we have our hidden fields with type, method, and target, and then we have a for loop for each form group. And there's less coupling here. It's still coupling, and if I had more time, I would make this even less coupled, but this should give you an idea of how you can decouple your front end from your back end by providing data with Hypermedia instead. So we don't really know much about the update action. We know that it's called update action. You have to have some kind of knowledge in the front end, but you reduce it a lot. So just to see that this still works. This is the response, and this should be the request here. You can see the same request, but it looks very different now. Now we're bound to schema.org properties instead, or attributes. So this has loosened up from the server, and we can even loosen up more if we take into account the possibilities of providing schema information for each field that tells the client this is a string, this is a date, this is an email, and stuff like that. That I didn't have time to do that in this demo, but just allow your imagination to just continue this path and expand on what you return from the server, allowing the client to be more intelligent and less coupled to what happens on the server. And to see that this actually works, we can open the here, and we can remove some of these fields. And just waiting for a recompile. And hopefully, when we edit this, we can only edit the name. So now we change the server, the API, and which fields it asked for in the client. And we have a change in the interface without the interface being redeployed or any change happening in the actual interface code. Every change I did now was in the server API. So, Hypermedia-based composition, it uses web semantics, existing standards, cache as well, and it's easy to argue for. But it's not a full solution. We need to use some of the principles Thomas demonstrated earlier as well. So when you combine all of these, we get the true composition and independency we want. And hypermedia controls takes effort to model. It's hard. But once you get up to a certain level, you can pretty much express everything you want as you can in HTML. And then you're free to do whatever you want in the API, and the front end will just react to whatever happens in the API.
I think we have to just.
And I don't think we have time for
Nope,
message-based.
We're going to skip a lot.
Yeah.
Also the considerations. I think to this slide actually.
That looks like the right
that
slide.
looks right.